All right, here we go. So I am going to go through our practice quiz. So you can always pause, rewind. You know, you have that option now since there is a video. So anyway, here we go. So when I look at this, again, I need to simplify this. So remember, if I have something in cosine and sine, those are the simplest functions, so I don't really want to change those unless I have to. So what I'm going to do is I'm going to start off by selecting my pen here. Okay, so I'm going to start off by working with cotangent. So I'm going to leave cosine the way it is, so cosine x minus. Now if we look at our cotangent function, we have two options. It's the reciprocal of tangent. Doesn't really help us here, but we also know that this is cosine x over sine x. Well, how does that help us? Well, it helps us because I have this sine x here that's going to be multiplied over here. So the way that that helps us is because now this sine cancels out with this sine, and I'm left with, bring this cosine down, so cosine x minus this stuff here all simplified to cosine x. Pretty simple. If we have cosine x minus cosine x, that is just 0. So that is what that one will simplify to. Next up, we have something that looks kind of messy. So what I'm going to do is I have two fractions being added together. So I'm going to get a common denominator. So this, actually let me move this over here. Oops. Let me clear that out. Just so I don't have to rewrite this first problem here. I am going to take this second function here and multiply by this denominator. So I'm going to multiply this by cosecant. Oops, that was supposed to erase. There we go. Cosecant x plus 1. Remember, it has to be a fraction equal to 1. So we got to multiply by that over itself. And this fraction over here, I'll multiply by that denominator. So cosecant x minus 1 over cosecant x minus 1. So whenever we have two fractions being multiplied, or I'm sorry, two fractions being added or subtracted, the first thing we should be thinking to do is get a common denominator. The only time you don't think of that is if this fraction somehow simplifies on its own. But this one doesn't because it's being added and subtracted here. So common denominator and go from there. So first fraction right here, I'm going to distribute my sign through. I'll do that in a separate step, but we have sine x times this mess here, cosecant x minus 1, plus, same thing over here, only with a plus, so sine x times cosecant x plus 1. Big fraction because they have the same denominator, right? These two things being multiplied together. I'm showing every little step. Some of you may recognize what that is. If you don't recognize what that is, no worries. I'm going to show you that here in this next step. So up top, we will distribute this through. Now, there's a couple of things we need to know. First of all, we need to know that sine and cosecant are reciprocals. So if I have sine x over 1, and I multiply this by cosecant, which is 1 over sine, these cancel out, and we're just left with 1. The other thing you should recognize is that anytime you multiply reciprocals, that is always equal to 1. Okay? So that's just something to remember. So when I distribute this sine through, sine times cosecant is 1. Sine times negative 1 is minus sine x. Plus, now I have sine times cosecant, again, is 1. And sine times 1 is sine. Well, that's really nice because our sines will cancel out. So that will end up cleaning up for us there. And like I said on the denominator, this is your difference of two squares. A minus b times a plus b. That's your difference of two squares. You can multiply it all out if you don't believe me, but it's the first one squared minus the second one squared. So first one is cosecant squared x minus 1 squared is just 1. Now, sine and negative sine cancel out. Add your like terms up top, we get 2. On the denominator, this is a Pythagorean identity. So 1 plus cotangent squared x is cosecant squared x. So if I subtract this 1 over, that means cosecant squared x minus 1 is just cotangent squared x. Okay, we don't want this to be left as a fraction. So what we're going to do next here is you can look at this as like 2 times 1 over cotangent squared x. Sometimes that helps to see it like that. But basically, when we have cotangent squared on the denominator, we don't want a fraction. So we're going to move that up and make it 2 tangent squared x. Okay? Which again, reciprocal identities, 1 over cotangent squared is, 1 over cotangent squared is just tangent squared. Okay, so that's simplified as much as possible. Next up, we have a verifying trig identity. So we will start with one side and end up at the other side. We have a fraction here. Typically, that's more complicated, so that's the side I'll start with. Since my right-hand side is in sines and cosines, that's another thing I'm going to do to start with here. So tangent is sine over cosine, so sine x over cosine x, minus cotangent is cosine x over sine x. Another thing we ought to recognize here is that this fraction, the big fraction that we started with, is the exact same on the top and bottom, right? They're the same thing, only this is minus and this is plus. So whatever I end up with on the numerator, I will also end up with on the denominator, just with that one little difference of the sign in the middle being a plus instead of a minus. Other than that, it's going to be identical. The process will be identical. Getting our common denominators is identical. It's just the plus and minus are the only difference. So kind of similar to that last problem, we need a common denominator. So cosine needs to be over here, so cosine x over cosine x. And sine needs to be over here, so times sine x over sine x. And again, some people will be like, well, how do I know to do that? Well, again, just like in the last one, if we are adding or subtracting fractions, going way back, even before algebra, you need a common denominator. So that's how we know to do this. With two fractions being added or subtracted together, we need a common denominator. Okay, I'm not going to rewrite that on the denominator because it's the same thing. I'll just remember it's going to be a plus instead of a minus. Okay, so it will be the exact same thing other than that small difference. So up here, sine times sine is sine squared, minus cosine times cosine is cosine squared, over, multiply your denominators, that's sine x, cosine x. And again, I have the same thing on the denominator. I'm not going to go through and redo this whole thing. It's the same thing, only difference is a plus instead of a minus, which is awesome because in one step I'll show you why. Maybe you already see it, but if not, you'll see it here in a step or two. All right, let me extend this down here a little bit. Okay, so fraction in fraction, what do we do? Copy, switch, flip. So I'm copying the top, copy the numerator, sine squared x minus cosine squared x, over denominator, sine x, cosine x. Change this to multiply, and you can put a little dot there. I wouldn't use x because we have x's in our problem, and we don't want it to look like an x. If you put an x there for times, I would just leave it as a little dot, or just write them next to each other. But anyway, this fraction bar means divide. So we copy the numerator, we switch it to multiply, and multiply by the reciprocal of the denominator. So sine x, cosine x, that's a c, over, if we flip that, sine squared x plus cosine squared x. Okay, a couple more steps to go here. So first of all, sine cancels with sine. It does not cancel with this sign because we have a plus or a minus there. So we don't want to do that. That is not legal. We cannot cancel that over a plus or a minus. We can cancel with this one, though, because it's being multiplied. Just like this cosine can cancel with this one because they're being multiplied and divided. So my numerator over here is sine squared x minus cosine squared x. This is a Pythagorean identity that's equal to 1. So this would all be divided by 1, but we don't really need to write divided by 1, right? Because if we divide by 1, we just get whatever we have on the numerator. So there we go. That's our right-hand side, and we are finished with that one. Next up, we have an equation. We have an equation here. We want to find all the solutions. Remember, all the solutions, this is the difference between inverse trig functions and actually the trig equations, is that we're finding all the solutions, 0 to 2 pi, which means every quadrant. So we need to look at this in all quadrants. Common thing people want to do not do this. Do not do this. People want to say, oh, well, I can divide by cosine and cancel those out, and everything's great. We're just left with sine. But the problem there is you just divided by 0, and that's illegal. We are not allowed to divide by 0. So when we're doing these, if you have more than one trig function, we need it to be equal to 0. So my first step is going to be subtract the cosine over. Get that equal to 0. And then the alternate to dividing that we did in the previous step is factoring. And a lot of times people say divide when they mean factor, but we will now factor out a cosine. So cosine x, they both have a cosine. Let me change the color on that so it makes it a little more obvious. Cosine x. So both of these terms have a cosine that we will take out. So what am I left with? Well, I took a cosine out here. I divided out. I factored out. I should use correct terms. I factored out a cosine. So I'm left with 2 sine x minus, if I factor a cosine out of here, I still have a 1. And that's another common thing. People want to just leave it blank. It's not blank. There's a 1 there. We need a place filler. All right, so we have this being multiplied right here, which means from algebra 2, we learned that we have two equations, either cosine x equals 0 or 2 sine x minus 1 equals 0. We have two possible equations here, and we will have to solve these. So cosine x equals 0, I'll draw the little coordinate plane here for those of you that need to see it. Cosine, remember, from your unit circle is your x coordinate. X is 0 at these 2 points, right? We have 0, 1, and we have 0, -1. Okay, so we need to know the angle measure at those two, and it's 90 degrees, or pi over 2, and 270 degrees, which is 3 pi over 2. All right, so those are our two, and you can start with 90 and 270, but then you need to change those into radians for your final answer. And again, how do we know it has to be in radians? Because we're told 0 to 2 pi and not 0 to 360. Next up over here, I need sine by itself. So add 1, divide by 2. Sine x equals, add 1, divide by 2. Sine x equals 1/2. This happens in two quadrants because sine is positive two places. It's positive up here, and it's positive up here. Okay, so we need to figure out what angle measure produces those this ratio 1/2. So sine is opposite over hypotenuse, so opposite hypotenuse, and you should recognize by now that this is a 30-degree angle. Over here, the 30-degree angle is 150 degrees. So in radians, remember final answer needs to be in radians, pi over 6, 5 pi over 6. There are your answers for that problem. And again, you know, the things that we did in Algebra 2, it was nice because we could see, okay, x squared means there's 2 solutions, x cubed is 3 solutions, and so on and so on. But for these, because we're looking at possibly a positive and a negative, or maybe 2 positives, or positives and negatives, there's just so many different ways that there's no set thing that you can look for to know how many answers you'll have for your final solution. So, but that's what we got for that problem. Last problem, again, when we're doing this, we need to remember it says use Pythagorean identities, so we need to use our Pythagorean identities to find the other 5. All right, so I am going to start off with just making a list. Okay, so let me change my size of my lines here. So I'm just making a list. I already know that sine is 5 over 13. I'll figure out what cosine is. I'll figure out tangent. I do know cosecant because that's the reciprocal, so 13 over 5. So we can use reciprocal identities, but other than that, we need to use our Pythagorean identities. All right, so we're going to take this information that we're given, this sine theta equals 5 over 13, and using a Pythagorean identity, we'll find out one of these other 4 that we're missing. Okay, but before we do that, we want to remember that this information right here tells us something. This tells us that we are in quadrant 2. Okay, why does that matter? Well, in quadrant 2, cosine is negative, tangent is negative, and then secant and cotangent are negative. All right, but sine and cosecant are both positive. And we know that because we're told in the original problem that it's positive. All right, so now we can go through and figure out some other information here. So we know a Pythagorean identity that involves sine and cosine. So we need to start with this. All right, sine is 5 over 13. So 5 over 13 squared plus, let's just recopy this, cosine squared theta equals 1. And we'll just go through and solve for cosine. So 5 over 13 squared is 25 over 169 plus blah, 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 rest of the equation. I need to get cosine by itself, so subtract 25 over 169. So cosine squared theta is equal to 144 over 169. I try to give you some nice numbers here because really I just want to see that you can do this process and not really focus a whole lot on like, can you do this with some crazy square roots and whatnot. Last thing we need to do is take the square root of both sides. Remember, whenever you do that, you need a plus or a minus. Now, if we did this over here already, we already know it's negative. So cosine, not squared anymore. I already did my square root, so cosine theta is equal to square root of 144 is 12, square root of 169 is 13. So that just gave me 2 pieces of information. Okay, that gave me, first of all, that cosine was negative 12 over 13, and negative, that should be a negative there. It also tells me that secant is the reciprocal, so that's 13 over 12. Okay, so we know those 2 pieces of information. Now, I'm also, again, I want to continue using the information I was given. So I'm going to take this cosecant x equals 13 over 5 and work with that to get cotangent. Okay, so copy down this blue stuff. It's about to get erased. So if you do not have that blue stuff copied down, pause the video and copy it down because I'm going to erase it right now. Okay, so I'm starting with, again, information that I know. I know that cosecant is 13 over 5. So Pythagorean identity, 1 plus cotangent squared theta is equal to cosecant squared theta. Plug this in, 1 plus cotangent squared theta. Cosecant is 13 over 5 squared. So 1 plus cotangent squared theta is equal to 169 over 25. Subtract the 1 over cotangent squared theta is equal to 144 over 25. Take your square root, and again, this is going to be plus or minus, but I already know it's minus because I figured that out over here, right? I already know it's minus. So, final answer, cotangent theta is equal to 12 over 5. So let's put that over here, 12 over 5, which then tangent is 5 over 12, negative. I forgot my negative again. We have it in our final answer over there, and that's why I like to do that, because sometimes I forget it here, but then I know that it's here. So negative 5 over 12, sorry, and not try to squeeze it between cosine and cosecant. All right, so that's everything there. Again, rewatch any piece that you need to watch again, and pause it, take notes, whatever, but that is your quiz.